All right. So today we have Juan Sequeda, principal scientist and head of the AI lab, and Dean Allemang, principal solutions architect. They both work for data.world, which describes itself as the data catalog platform for your AI future. And also, one of the phrases I grabbed from the website is when the world's data is transformed into knowledge, opportunities emerge for everyone. But for this episode, we are not going to talk about data catalogs. Rather, we are going to talk about the results of a new paper that they just put out entitled A Benchmark to Understand the Role of Knowledge Graphs on Large Language Models Accuracy for Question Answering on Enterprise SQL Databases. This is the longest title of a paper ever. But with that said, welcome to the Data Exchange Podcast, Juan and Dean.
Well, thank you very much, Ben. It's been a pleasure and honor. I've followed you for a long time, and I have to say, yeah, it was a long title, but I just wanted to make it super descriptive. So,
all right. So let's start with the basics, which is so why did you folks decide to study the role of knowledge graphs in LLMs? And by the way, before you answer that, so Q&A system, is it fair to say Juan and Dean, in kind of the more recent parlance, this would include retrieval augmented generation?
yes.
Okay. So for our listeners, keep that in mind as we do this discussion. So what's the motivation? Why did you bring in knowledge graphs into RAG systems? And I know that our listeners may be familiar with this because obviously I wrote I wrote a post kind of promoting this idea. But aside from that, I think at a basic level, most people, I think by now, kind of acknowledge that metadata, for example, helps RAG systems. So with with uh, with that in mind, you would imagine that even more structure would help a RAG system. So what's your motivation for studying this?
So let me kick it off, and I'll pass it quickly to Dean then. So first of all, with the whole launch of GPT, right, a year ago now, right, it's the whole chat with your data, the chatting interface is what got people really excited. And I think everybody's been working on the chat interface over mainly text and unstructured PDF type of documents, right? So current RAG things, it's like your chunky and all that stuff. But what happens when you have your structured data in SQL? So that's a big question. I think what we've seen up to now, and everybody you talk to from an enterprise perspective, they look at the current text to SQL approaches, and everybody acknowledges it's cute. All the examples are really kind of on small data, on easy questions, and so there's a big disconnect from the enterprise. Now, also remember that text to SQL has been worked on for decades, so this is not a new thing at all. Now, of course, people are trying to go tie this LLMs over your SQL databases, but all the conversations are about the text. So we're like, okay, what happens with the SQL side? And when you look at all these kind of really just quick experiments, it completely fails. Now, our hypothesis has always been that the knowledge graph semantics, that's the key, because it provides it bridges the gap between the technical infrastructure and what the businesses are thinking about. Now, specifically, I was at the Snowflake Summit back in June, whatever, right, in Vegas, and this is when they launched their whole LLMs and all the stuff they were doing. We were talking to a lot of the product people at Snowflake, and they're like, yeah, we get that we need semantics, we need knowledge graph, but one, we don't know how that actually would look like, and second, we don't know how much that would actually improve. So it was actually folks at Snowflake and product at Snowflake who kind of really like challenged us, saying, hey, you guys should do a benchmark around this stuff. And I left that meeting, I'm like, oh shit, yeah, we should. And I told Dean, right? Dean and I are in the lab, like, let's go pull this off. And that's what we did for the last couple of months. So that's kind of really the motivator of a bigger picture, and then very specifically from like Snowflake. So thanks, Snowflake.
Yeah, so my story sort of dovetails into that. Back in May, I was at the Knowledge Graph conference in New York, and a lot of the knowledge graph companies were showing text to Sparkle. And I think I saw 2 demos there. I had done a demo of myself that I blogged about way back in March. And it was like, okay, and we went from nothing to that cute level that Juan was talking about. And I thought to myself, I wonder if it really does help. to have a knowledge graph, or if all we've done is to discover the fact that LLMs can speak SQL. And then I went to that same Snowflake meeting that Juan was talking about and discovered, not to anybody's surprise, that Snowflake had done the same experiments that I had. They had read my blog. Yet this is a obvious thing to do in the technical sense, the word obvious. Everybody was doing it, and everyone was wondering, how do we do it well? And the only way you can tell if you're doing it better is to have a way of comparing. And then in that same meeting, Snowflake said, we need a benchmark. And so when Juan said, hey, we got to do this benchmark, it's like, okay, I'm 100% with you.
So the experimental setup is so your starting point is you have some sort of data warehouse.
Mm-hmm.
Is that correct? And then from that data warehouse, you can automatically impute a knowledge graph.
So not necessarily, no, so it's not automatically. That's the whole point here. So if the main conclusion of the work is that by investing in knowledge graphs, you provide higher accuracy for these large language model powered chat with the data systems. So you had to invest in knowledge graph. We had to do the work to say, oh, this thing in the source database means this concept over here, and these columns, you define these mappings. So in the benchmark, what we did was, one, we provide an enterprise SQL schema from the insurance domain. So this is OMG, is a standards organization. They provide something. It's like 200 tables. So this is a real world enterprise schema. And then we created the context layer. We did that work, right? So you created the ontology, the semantic layer, and the mappings from source to target. That was the investment that was done. And then also the other aspect here is on the types of questions. So what we looked at the questions was basically two spectrums: easy questions to harder questions. Easy questions, day-to-day reporting; harder questions, metrics, KPIs, things I ask for strategy. And from a technical perspective is, do I need a small amount of tables to answer, or do you need a larger amount of tables? So you get a quadrant there
So 200 tables to me, Dean, suggests that you guys were looking at a OLTP schema rather than a star schema.
Yes, this is an OLTP application schema.
And then I thought for some reason, and correct me if I'm wrong, because I'm not as deep into this space as you guys are. I thought for some reason, if you had a relational database, it's not too much of a lift to take that and kind of impute a knowledge graph out of it. No?
Well, Ben, yes and no. Before the LLMs came by, what we would say is that you would build a knowledge graph over your data. We would emphasize it being not a huge lift. It's sort of like talking to your business SMEs about what they're doing and connect that to your data. After all, the data is doing some work in the business that shouldn't be that hard.
Yeah, because you also have a schema, right?
Right, yeah, and you have a schema at this end, you're building the model from the business, and there's some work to be done there. And that once you do that, this is before LLMs, what we claimed is now you get a federated view over all of your data, and you start getting words like data mesh and data fabric and stuff like that to describe what's going on here. I even wrote a book for O'Reilly about 2 years ago, which I consider to be completely out of date now, where I talk about using a knowledge graph to build a data mesh. And then the story was, yes, it's not a particularly high lift, and it's worth the effort, but that never flew. Nobody ever did that. Sorry, light as that lift is, big as the effort is, programmers would rather just build an application. Data managers would rather just build another database or maybe another data warehouse. Sorry, that lift, light as it is just too heavy. What Juan is arguing now is the lift is exactly the same, but now the benefit has exploded. Before we said you can get a data mesh, you can write your queries a bit easier and so on, and that's true, you can demonstrate that, but now we're not writing the queries anymore, the LLM is, and it can do them easier as well, and that gives us this amazing chat with your data capability.
One thing to add here is, I think, kind of if you have your application database well defined like the textbooks, it probably is kind of very reflective about it, but in practice that isn't the case, right? Yeah. So why is there 10, 15 tables with the word order in them, right? How do I know what a customer is? You have to go figure out, like, not all the humans will know what this stuff, but there's a 50 columns. Which one is the right one?
How many times is my address repeated in there? You know, all of these non-normalized things.
An entire book called Designing and Building Enterprise Knowledge has all the different mapping patterns to go define this. Like, so if you have a really well-defined third normal form database, then probably it's kind of going to be easy lift. But in reality, enterprise applications,
And in my career, I have never seen a database in an enterprise whose normal form you could even figure out which one it is, because it's so hybrid, bits and pieces and stuck on. And most of the time it's not even declared. Some bit of software understands it. I've never actually seen a database in use that matches anything like what you learn in a database textbook.
So this insurance database example was just out of convenience because it was out there. It was like released. It's a real world
Free.
example. It's not
And it's free.
synthetic data.
Yeah, it's free. And I think another thing I want people to take away from this is that, yeah, we provided this, we're using this existing thing, enterprise schema that's been created for a while. But also think about it, the contribution of our work is the framework of how we did this evaluation. So what I want other people to say, like, oh, I'm creating my own chat with my data system internally. Well, the framework is you have your schema, good, okay? Think about your questions in those quadrants that we presented. Easy questions, harder questions, right? Questions that need 2-3 tables to answer, 4 or 5, 10 different tables. Think about those questions and figure out that quadrant and put those questions there. And then also do the work on the context layer, right? And now do your experiments, because at the end of the day, like, we're presenting some numbers here that we're making generalizable claims, but what I'm hoping is people who are listening and they want to bring this to the enterprise, you need to be cautious too, and you need to be skeptical and say, let me go bring this into my own enterprise, which I'm not going to share with anybody in my own private data. Think about that framework as a way to evaluate, because at the end of the day, you may realize I'm going to get a great lift on these easy questions. Maybe that's all I'm going to go do, because these harder questions, I can't figure it out. And again, this is the type of stuff that we need to go figure out. So look at the framework as a contribution.
So this quadrant of questions, easy versus hard, has to do with the SQL that you need in order to answer the question. So a question is easy if the SQL statement is relatively straightforward. It's hard if the SQL statement is convoluted.
There's
So
actually a couple different dimensions of easy and hard. Go ahead, Juan.
Yeah, I was going to say, so from a question perspective, easy would be just day-to-day kind of question reporting. Give me the list of things, right? Questions get more complicated when they involve some sort of.
No, but you must have like a principled way of.
Yeah, so what we did is that easy questions from a technical perspective, you're just doing selects, just projections over less than 5 tables. And then if you're doing more complicated questions, you're now joining more than 5 tables, and you're going to have things, aggregations and then functions like math and stuff like that.
And why? So remind me again. So the reason you have these categories of difficulty of the questions is for what? So in order to for evaluation purposes, in other words, does this approach work? Yes, but only for easy questions.
Exactly. And so if you think about it, the research question that we had is, to what extent can LLMs answer questions over SQL directly, and to what extent can the knowledge graph improve? So I'm thinking about an extent, right? So I'm looking at a spectrum. So part of that spectrum is to understand what is the spectrum of complexity of questions. And if you look at the results that we had, if you go to the high complexity questions, so on that extent, on that larger side, the SQL without a knowledge graph had 0% accuracy, right? So we learned that, but then actually, if you look at a lower complexity, there's still accuracy without the knowledge graph, but with the knowledge graph, it always improves. So again, the question here is the extent, and that also helps us figure out where we should go focus. So I've been talking to a lot of people that realize, oh, wow, maybe I should not invest. I should not think about working on this problem to solve all types of questions. I should focus on answering the questions that have low schema complexity, right? Mm-hmm. Now I know where I can figure and kind of invest my resources and my time and my energy around that. And I think that will help us all as an industry kind of progress and show more results.
And so keep in mind that at the beginning of this, there were a lot of folks doing demos that worked really well, but then Snowflake themselves, but it falls down after a certain while. Well, what makes it fall down? That was the sort of the $1 million question.
And so the evaluation data set is what? So here's a set of questions that the insurance guys came up with, and here's the right answer, or here's the right SQL statement?
It's the right answer.
Okay.
And there's a reason why we did this, because if you look at existing benchmarks, academic benchmarks, a lot of the evaluations are comparing the generated SQL. And our argument here is that by focusing too much on the type of query that's being generated, you are dismissing you're pushing your energy on the part that we really don't, that's not as important.
Yeah.
What we care about are the right answers. You can give me a really efficient query, but if it's not, doesn't generate the accurate results, I don't care.
So wait, so the SQL statement that you're comparing against is the SQL statement generated by the LLM.
So you would take it's the answer that the query generated from the LLM compared with the correct answer that's given in the golden.
Yeah. So basically, here's a question. LLM generates a SQL statement based on that question, and you compare against this SQL statement.
Right, and we have reference queries that we have made for the same question. So Juan sat down as an expert in SQL and in Sparkle, and someone who knows about the database. He said, "Here." So
Juan messed up some of this.
So he is the
messed
reference.
up some of the. One SQL did not work in some places, is what you're saying.
No, yeah, and the LLM was smarter. Yeah.
But I think the reason why I don't want to kind of focus too much on the generated SQL query or the Sparkle query is because at the end you want to generate you want to compare the system. And the system is going to do things inside. It's going to and I honestly do not care what the system is doing inside. I just want to know, does that system generate accurate results?
And if you look at the history of text to SQL, they do the same approach. They have sample data sets, and actually we borrowed some of their open source code to actually do the comparison. I got a table, Juan got a table. Are they the same table? There are some fast algorithms for doing that. Spider has those. I just plucked them over.
Plus, honestly, SQL also is a bit of an art form, right? So people write SQL statements in their own way. Some people use a lot of subqueries.
And the same is true of Sparkle, yeah.
Yeah. All right, so then high level findings, obviously amazing, right? So otherwise, why would we be here? So now that you have these hierarchy of questions, is it so at a high level, basically the use of knowledge graph helped across the board?
Yes.
Yeah.
That is the evidence that we're providing. And the claim that we're making is that by investing in knowledge graphs, right, you are going to generate higher accurate results. So what my call for everybody listening is, if you want to use large language models, and specifically I'm focusing on your structured data, on your SQL data, you need to invest in knowledge graphs, because if you don't, you're going to be working with stuff that you can't trust. And why would you do that? Like, not using knowledge graph, you're setting yourself up for failure.
Now, what is the architecture of the resulting system? So now you have a text interface, and then you have a database at the on one end. So where does the knowledge graph sit in this architecture?
Okay, so we have a couple of Git repositories out there. One that just has the knowledge graph, as it were, that is, say, the data, the ontology that describes the data in the knowledge graph way, an R2RML file that maps those together. So this is all standards based, but it also has the data warehouse. It's got the DDL for the data directly. So this gives you sort of the knowledge graph as well as the warehouse. So now it is set up so that you could come in here and in your own technology stack, build your own system. That's just how the data is published. And then, the questions. And then we have, and I've published this in RDF. I haven't switched to JSON yet. And if somebody asks me to, I'll do that. There is our list of questions, and those are categorized in the 4 quadrants that Juan described. And then those are linked off to the reference queries that Juan wrote. I don't include the answers because that could get quite large.
No, but I guess my question is architecturally. So now I have a database.
Yeah.
So then the knowledge graph sits in what, a graph database?
So for the execution of our experiment, the knowledge graph sits in data.world. So data.world lets you put an ontology, a mapping.
Let's set that aside, this commercial.
Yeah.
Yeah.
That one.
So that's why I went to the first part of your question, not answering that part, because I didn't want to make a commercial. But
Yeah.
I'll just talk about standards.
Okay.
The R2RML standard says, give me an ontology, I describe the mappings, and give me a database interface to a SQL database.
I see.
And here's what R2RML says. Write a query against that ontology, a Sparkle query that conforms that ontology. I will convert that into SQL against there. I'm not advertising any stack that does this. I could name 4 that do it off the top of my head.
Yeah, so
Any
what about Cypher?
So what we invite the world to do, I don't know Cypher. I didn't put Cypher in. I would love to see the Cypher folks pick up the data I described, the tables, the DDL. If they want the ontology, they can use it. I don't know if because there is a Cypher semantics out there. It could probably use that. I don't know. That's up to them to decide. And then build onto that a Cypher graph layer, whatever that means to them, and do their own experiments and say, you know what? If we add whatever, we can get better or as good, or combining. What I really would love to see is that the Cypher folks say, we can improve it too. The way you improve it, the way DBT improves it, everybody improves it, and we can use them all together. And now we get something that really advances the industry, not just any one of us.
So to add to this, the part of the benchmark presents what we're calling the context layer, right? So the ontology, your semantic layer, and the mappings from source to the target, and those are in standards, right? So the OWL ontology and R2ML mappings. So what we did for these experiments is that we used a virtualization layer to we virtualized the relational database. So your relational database stays where it is, and we virtualize the knowledge graph. So you can query it in Sparkle, and then with the virtualization engine, that Sparkle would be translated to a SQL query using those mappings. You could have also used that to generate the graph data and store it into a graph database. And you can do that in an RDF graph database. I actually am chatting with Neo4j folks soon, and I would love for them to go run this experiment too and put it into their Cypher, because I'm sure that we'll get the same results or even better. We'll see that. And actually, just this weekend, we just saw DBT took it, and they actually are starting to replicate the same results. And they took the semantics and they put inside of their DBT models, and they're replicating it on their way. So at the end of the day, we're presenting kind of the work that we presented here was using virtualization, using RDF. At the end of the day, put it in Cypher, put in DBT. The point is you invested in semantics, and that's the most important thing.
So for teams who are listening to this, so I guess the main takeaway is, if you're going to do a natural language interface over a database, use a knowledge graph, right?
Yes.
So then the question that they'll ask is, but we don't have any knowledge graph people. So, outside of hiring data.world. So what pieces of advice can you give? So start small, start with a simple database, or so how to get started.
So again, recall that the main claim we're making is invested in knowledge graphs, right? So now we're trying to convince people, go invest in knowledge graphs, and you're asking the great question.
Especially Juan, so just to make sure people understand, so the main claim is invest in knowledge graphs. Broadly is what we think, but specifically in this conversation, there's evidence that if you're going to do kind of a natural language interface over a SQL database, knowledge graphs are a must.
Exactly.
Yeah.
So that's one. So now the things that the next quest here is, how do we reduce the cost of that investment? And you're bringing up this great point, right? So I think one is, hopefully Dean and I both come from the semantic web and knowledge graph world. So hopefully part of this is a call for people getting excited about this and learn more about this technology. So that's one point. Education. I have a book. Dean has a book. There's so much books to be read out of it. So let's get educated on ourselves around that. Now, and then there's open source tools around these things, right? Take a look at these knowledge graph tools. Now, from kind of actually starting in practice, of course, start small. And again, I think this is why I'm really calling out the whole benchmark framework. Look at those questions that you are interested in. So actually ask people, what are the most important questions you're trying to go ask, and categorize them. And then start with the easy questions and try to go build a knowledge graph that models and represents those set of small questions first, and then start showing progress there, and then add more questions, and you start increasing the knowledge graph little by little. I think so. It's really an agile, iterative, what I call pay-as-you-go approach to start building this, and I think you learn and you start showing results at the same time.
Let me ask you guys this. Does your intuition support the following claim, which is basically, I have a database. I know there's tools out there that take that database and create a knowledge graph automatically. Maybe, as Dean points out, they're not perfect.
Mhm.
But now I have a knowledge graph. It's not perfect. Do you think that with that kind of automatically generated knowledge graph, I'll immediately see value?
I think
When-
so.
Yeah.
And the reason I say that, in some sense, it sounds like you're getting something from nothing. And so the answer should be no. But actually, one of the things that happens when you build these knowledge graphs in automated ways, yeah, it leaves a lot of stuff out. But one of the things that it does is at least take data from different places and give it a single name. And that's not much, but it's also something you can do fairly syntactically. But from the point of view of a data mesh, it's actually quite a big step in the right direction. And I don't think you're going to get numbers as big as what we got in our benchmark, because that was actually a curated knowledge graph. But this is relating to what Juan just said. This is your sort of 0th step. Now you can go in and say, well, look, that thing built a knowledge graph in kind of a dopey way. It really should have, and now you are improving your knowledge graph.
Yeah, exactly.
And in fact, Ben, one of the things that I think could happen here, a friend of mine has written a book about how to do knowledge modeling. It came out about 2 years ago. I think her book is also obsolete now, because if you take a knowledge graph and instead of saying, how does it fit to your use cases? How does it fit to your software engineering model? Instead of saying, no, how well does it improve the LLM's performance? Now you actually have a metric that you can use to say, this ontology is better than that. And it's not subjective at all. It's quite objective. You've turned what used to be an art and craft into an engineering science. And this is the way I really see knowledge graph construction is going to be going in the future, is that we will measure the quality of the knowledge layer, the ontology, by how well it helps us answer questions.
And I think another thing I wanted to add here is this is where LLMs also are going to help to reduce this investment. I am going to use LLMs to help me build that knowledge graph. So this is something people can use right now. Go talk to business folks, whatever, and ask them, what questions are you trying to go answer? Or go figure out what is your dashboard most used and what questions and people answer with that. Take those questions, put them into ChatGPT saying, I have these questions people are trying to go answer. Please build a knowledge graph or an ontology or a semantic layer for it. Boom, it will spit something out, and then shop that around, share that. Is this what you mean by this? Is this what you were, I mean, this is what the visualization of the schema looks like, right? And then from there, you want to say, well, what is this thing, this concept, customer, what does that actually mean? And try to get it more granular to the data. And another thing that we've also done ourselves testing is can I use ChatGPT to help me create the mappings, the transforms? Of course. Does it do it perfectly? No. But it gets me more than 0%.
Frankly, Juan, I wrote a blog about that way back in February, because when I started looking at ChatGPT and the generative AI, my attitude was like a lot of folks. Yeah, this is a cute little toy. It'll never amount to anything interesting, until I saw a post by a friend of mine, Adrian Geschwind, who showed it doing a mapping between a knowledge level and a schema, and it did it really well. And it's like, whoa. And now what it's doing is it's doing the elbow grease work. When you do these mappings, 90% of it is obvious to a human being who understands both sides. But that's 90% of stuff that you need to have some affordance and some user interface, and it blah, blah, it takes a lot of time. Now that 90% is done by the LLM. The last 10% that actually requires insight, that's where you focus your SMEs and your data engineers and your ontologists and so on. Suddenly, these people are now working at 10-to-1 higher productivity. And that's what really got me excited about LLMs back in January or February of this year.
Yeah, because my thesis is that I think that knowledge graphs are going to be useful, but the problem has always been that the creation of the knowledge graph.
Yeah.
And for some reason, there's never been enough motivation. I think maybe this result will motivate people to do at least even the rudimentary knowledge graph
Yeah.
with these automatic knowledge graph generation tools. Which, by the way, so if you pre-process your data a little bit, maybe do some entity resolution using, for example, Jeff Jonas's tool sensing,
Yep.
right?
Yeah.
So, and then now you've got resolved entities. You do this automatic knowledge graph generation tool. I'm pretty sure that you're gonna see value.
I'm
Someone
sure
just
you're right.
needs someone just needs to create some resources to do step-by-step examples, almost like a cookbook
Mhm.
type resource material, so that
Well,
people.
I think, I mean, I have, Dean has a book, Semantic Web for the Working Ontologist, that has this cookbook. I mean, I have my book, here it is, Designing and Building Enterprise.
No, but it has to be online where you can just.
Yeah, that's a fair
copy
point.
paste,
So
yeah.
so this is a good call out, and I
And all of our books were written before LLMs, Juan. We need to update all
we need to
of them.
update. And I think also part of it is to be able to understand where you use LLMs themselves to go build the knowledge graph. That's why it's just like this. I always say it's like a peanut butter and chocolate. It's this perfect match right there.
Now, knowledge graphs are in some ways, are maybe I'm off base here, but the impression I get is, they're always works in progress anyway. You're constantly polishing them, so you might as well kind of get started using somewhat of a not the perfect knowledge graph, and you constantly polish
Yeah.
along the way. What's your guys' take?
Well,
I think that's exactly right. I mean, your understanding of an industry changes as well. Your understanding of an application, your business changes. If a technology can't be a work in progress, if you've got a database technology that's frozen in stone, it's out of date shortly after it's done. This is a feature, not a bug. And indeed, the knowledge graph technologies are in some sense designed to be exactly like that. So you can get incremental value from incremental effort as you move forward. And that means that you can actually do what Juan likes to say a lot, is to crawl, walk, run. No, that doesn't work in all situations, but I think in this situation it does. You actually can start, get a little bit of value, and then a little bit of effort, a little bit more value, a little bit more effort, a little bit more value.
So how does so we're making claims that a rudimentary knowledge graph in this context of text to SQL kind of problem will immediately show value. But if I'm a developer inside a company and I do proceed along these lines, right? So I take one of these automatic knowledge generated automatic knowledge graph generation tools, and I implement your guys's architecture. How do I prove inside the company that I didn't waste my time?
Well, I think this goes back to like really understanding the business, right? What is the business trying to go do? So from things like, one is like who's asking what type of questions, right? And to go prove, I need to provide some metrics, right? So it's like, do I have metrics of how many people are asking questions today, and can I improve that, right? That's already an improvement, evidence I can go show. Second, I think it's also is the trust factor. I mean, one of the things I've been talking to people, they're like, oh, but the accuracy isn't 100%. It's like, yeah, that's true. This will get better for many reasons, but also you're answering questions today, looking at a dashboard, a report, or people's giving you like, what is that accuracy? Do you even know? Do you even challenge that or not? Right. So I think those are the types of questions that we need to start asking ourselves. So at the end of the day, to really kind of show the how much impact you're making, well, you need to understand what are the metrics that you're going after. And that means that you also need to understand how the business works. And this is why the semantics knowledge is so important, is because it connects the data with the business. And this is another reason why you want to go invest in it, because I'm going to learn so much about the business, and then I'm going to understand where I can go focus on to provide more value.
So Dean, do you have anything to add in terms of for developers who want to actually get going on this, and how they improve their chances of convincing their organization?
mean, there's sort of anecdotal stuff, and we're not into this far enough to have real data. But anecdotally, we did a hackathon with a customer recently, and I won't name them, but they have their customers who are asking questions of their data, and they've done this approach of basically getting a catalog of questions and having the questions have their own answers in the back, and their customers are constantly frustrated because they always have new questions and they don't feel like they have the freedom to actually explore the data. I'm avoiding saying chat with your data, but that's what they really want to do. And so what's happened here is that just by doing a quick hackathon level demo, they were to come in and saying, okay, we've got a representative from a customer in the room, and they start asking questions, and the system performs badly. By badly, I mean around 75%. Badly in that sense is spectacularly in comparison to what they were used to. So as is always going to be the case, you're going to impress the business when you can actually focus on business problems that they feel pain from. And in this case, the problem that they were feeling pain from is their customers are asking new questions. That happens in a lot of industries. So that's where this is going to go. Find the places where flexibility is something that someone needs, and then show that you can do this better than any other system they've even dreamed of. And you actually can do better than ever dreamed of, because that's what's happening today.
I'm glad you brought this up. Here's something for developers to go do, like organize a very quick hackathon, right? Have a buy-in from the business side of somebody who's like, yes, this is a great opportunity. So they know they're going to bring in some folks. They know that they're going to bring in like the right questions they want to go answer. And 2 days, because this is what we've done. We've already done this before. 2 days, and you start from zero, and you show 2 days later what they can do, and people are going to like, holy moly, look at the stuff. And it's not just about the accuracy, because the other thing when we did this was also on the explanations, because that's the other thing that the knowledge
and accessibility, right? Because basically now you have people who can't write SQL interact with the system.
Yeah, that's a big given here. Like that's the obvious, that's the obvious win right there. Another thing,
and not only that, so accessibility, but also kind of feeling of empowerment, because what if you also somewhat create a system where the people who know the data, the domain experts, contribute to the improvement of the knowledge graph?
Bingo. And this was something that we did during that hackathon, is that we had kind of business level folks part of the hackathon, and we were like, so what do you mean by this? What do you mean by this? Look, and they were part of that, and they were helping design the Untitled. By the way, for this hackathon, kind of as an e-commerce result, we just focused on who bought what. So it's like the customer, the orders, and the products, and they had all this data that were coming in from different types of e-commerce systems. And once they were part of that modeling process, so they felt ownership. And then when they actually asked the question, they saw the results and they saw the explanation, they're like, yeah, I know this, I trust this, because this is actually talking my words. And they felt that owner, and they wanted more. So now it was an easy way to get the investment.
So early on, Juan used a dirty word in my mind.
Which one? How many have I said?
RDF. So it seems like to me that the RDF is kind of, you guys are like a subculture off on your own, right? So maybe it might be better if this whole thing is more in the Cypher world. You know what I mean? So what's your guys' take? Of course, you guys are biased.
Well,
in favor of RDF. But RDF to me is like its own community. They have their own conferences, its own world, right? So am I wrong?
So I will say this, and then you go very quickly. Having this quote unquote battle between RDF and Cypher and property graph is a disservice to the world, and everybody should stop doing it.
No, it's not a battle.
It's YouTube, Ben. He means YouTube, Ben.
No, I see this.
It is a disservice to the world. You called him. You said he said a dirty word.
Exactly.
You have done a disservice to the world.
You just said that this should be Cypher. I'm like, no.
The impression I get is I'm not in either world, right? So the impression I get is that the RDF is older, so they're much more kind of their own thing.
Yes,
this new world of property graph seems to be broader. So it might be helpful if a lot of these things are framed in that world.
And they are, and so you talk about Emil and I are great friends, and Jesus Barraza, which hopefully you've seen the work. We're academic relatives, like we've worked in these both worlds. We just need to build more and more bridges. And I applaud what Neo4j and these folks are doing, like all the semantics, the Neo Cypher and all that stuff, the Neo semantic stuff. We just need more of that. At the end of the day, it doesn't matter. You just want a knowledge graph, and then you can just decide whatever tool that fits best. The folks at Amazon Neptune, they're doing their one graph, and it doesn't matter what you want to go do, right? This is going to evolve, and it is evolving. And I think now having these LLMs is a big fuel to getting more of the knowledge graphs. And I mean, in 5 years from now, I would bet, hopefully, this is just going to be like, it's just another tool that you use.
And so a comment I like to make to this, Ben, is that for years, I've been trying to convince the world that Sparkle is easy and Sparkle is a lot better than SQL and so on. And I failed. And so has everyone else. We failed because we're a little group of our own out in the corner, just like you said. But something amazing happened in March of this year. I went to an LLM that I had never, ever seen before. And I said, write me a Sparkle query to do this very complicated task. I consider myself a world expert in Sparkle. ChatGPT 4 is better at Sparkle than I am. You know what? I don't need to convince anyone ever again, because already the LLM speaks Sparkle so well. Why? I don't actually care why. Do they speak Cypher as well? I hope so, but I don't know. I haven't done that. So should we switch from Sparkle to Cypher? The LLMs will speak things very well. And this is a complete non-issue. The LLMs are going to be doing all this work for us. I've already shown that they speak Sparkle really, really, really well. I bet Jesus is going to show that they speak Cypher really, really, really well. I don't know. I haven't shown that yet, but I bet it's true. And now we're not going to write queries anymore. We're going to let the LLMs do it for us, and it makes no difference at all. And so the communities that brought this here, wonderful. They are wherever they are. Going forward, we now can take advantage of all of this stuff.
So what's the next step? Is it kind of assumed that this thing generalizes in the following sense, right? So you guys obviously did this for this insurance database. So the idea is the belief is that this will extend to just about any database.
Yeah, so that is something that our intuition says so. And I think,
are you guys going to do?
One of our goals for the next quarter is, in fact, to take the same story and apply it to at least 3 different areas. To at least, we can't prove that what you just said is true, but we can demonstrate that it's probably true. Let's just pick up the same approach that we did in the hackathon, go to someplace brand new and do it again. Is this a repeatable process? I think it is. We didn't do anything particularly special.
And what would that entail, Dean? So most of the work will be creating the knowledge graph and coming up with the bucket of questions. So how long does it, if someone hands you a database
in 2 days.
Yeah. I see. So if someone hands you a database in 2 days, you can kind of test
for everything for a handful of questions that you want to go start on, right? And I think it's going to be an evolution, right? People are going to keep adding more and more. So I think, again, what I really hope is, like, again, back to the framework of the benchmark, people should be able to go apply this for their own domains. We're doing this internally, internally in data.world and with other customers. We're already testing this out. So on one side, what's coming next is kind of figuring out this playbook. Remember I said invested in knowledge graphs? What is that cookbook, as you said, and how do we make sure that the cost of going through that cookbook is really as low as possible? We're going to be using LLMs for that. We're already doing that. So that's one thing. Second is we want to improve the accuracy. And we're already testing different techniques to go do this, to improve technically through prompt engineering, through more like some static analysis of stuff. So those are like the 2 main things that are like kind of very short term that we're working on.
But the driver of accuracy one would be the getting a better and better knowledge graph, no?
Yes, that's one. But also, so if we look at the results of the benchmark, we did an analysis, a manual analysis on why wasn't it accurate? So we saw 2 things. One, there's a notion of partial accuracy, which was like, oh, it returned results.
Is that like alternative facts?
No.
A subset facts.
Subset, yeah.
No, so it's like, oh, the results that you did return were correct, but you missed some other things, right? You missed some of those things. So, but in practice, a user would see that and they're like, oh, this is not wrong. Then you'd kind of say, hey, you missed this, right? And then when we looked at when things were incorrect, and we actually saw like the Sparkle query, the graph query was incorrect, it got the wrong path wrong. And so instead of going from A to B and from B to C, it went from A to C. Oh, that's a problem. We can do static. We can check that. That is a deterministic problem. So there's a lot of techniques that we're looking into. It's like, oh, just by actually looking at the types of questions, the results, we can probably improve that. But then also, you said that's why we're also investing more into how do we figure out better processes to be able to create that knowledge graph such that the investment is lower. So a lot of the stuff, and we're going to start blogging about all our work and what we're doing, and looking forward to getting people's feedback too.
And this resource that I said, which is a step-by-step
Cookbook.
Playbook, a cookbook, would be, because a lot of these things take off if a single developer can do something that is powerful, and then they can go and tell their friends and impress people inside their company. But if it entails a lot of work, it's just harder for it to take off.
So you started off this conversation asking us how this all got motivated. And I said, well, there was a conversation we had with some product boats at Snowflake. So today, I'll mark the day, is that you are basically challenging us, where's that cookbook? So we challenge accepted. We're going to go work on this and share it with you, Ben.
Well, I'd say we actually already are, but it's, we have to generalize the work that we're doing. Because we're, for particular customers, we're already doing this, but a run book for our customer is different from a playbook.
Or what I'm saying is, here's a step-by-step thing with all of the resources I have, and then I can plug and play my own data.
Yep.
Right.
Yeah.
What is the natural next step here? So if you look beyond SQL databases, what is the natural next place to tackle with this kind of approach? I mean, obviously PDF files and all.
Yeah. So I think it's understanding or defining this architecture, the RAG architecture that combines knowledge graphs with vector databases, so you can be able to combine your structured with your unstructured. And I think this is like the
this is a hybrid analytics kind of thing, right? So where you have structured and unstructured in there.
And like when it comes to like the vector databases and stuff, like I want the knowledge graph should be in the vector databases, vector databases. I should be able to kind of represent things in the vector database inside the knowledge graph. Like there is so much stuff going all around that we need to go figure out. And I think this is the fun thing coming up next. And I think everybody is tired to talk about it. I think the conversation has started with like unstructured chunking of text in vector databases. Now knowledge graphs are coming along, and I think part of the new RAG architecture, which I'm starting to see, is vector databases and knowledge graphs are the two components over there that provide the context to the LLMs.
And honestly, I think developers already get, even metadata filtering, as I mentioned, is very powerful. So, and with that, thank you, Dean and Juan.
Well, thank
Been
you.
a pleasure, Ben.